With the same argument, we can write down more statements like this. Another theorem for you. For all sets like A and B, A is a subset of union between A and B, and also B is a subset of the union between A and B. Another theorem for you. Remember, we defined transitivity for all sets like A, B, and C if A is a subset of B and B is a subset of C, then we can conclude that A is included in set C. A is a subset of C. Remember, this is called the transitive property. Excellent. With the same argument, using the definition, we can easily prove each one of these statements. In general, we can list the laws for sets, and we have specific name for each one of them. Let's list some important ones here. Set identities. Let U be a universal set. And suppose you have some sets in that universal set. First of all, we have the commutative law. It means that A union B is the same as B union A, and also we have the same law for intersection. A intersection B is the same as B intersection A. So the A and B, the sets commute over this operation, union, and also the intersection. Associative law which says, well, which one comes first is not important. If you take the union between A and B, then take the union with C, it's the same as taking the union of A with the set B union C. So the order is not important at all. We have the same thing for intersection. A intersection B, intersection with the third set like C is the same as taking the intersection between A and the set B and C. We can do the distribution as well. So distributive law, you can distribute intersection over union, also union over intersection. So A union B intersection C, you're using union to distribute over the intersection. So here you have A union B intersection with A union C. Also, You can distribute intersection over union. A intersection B, union with A intersection C. From left to right, and also from right to left. If it's written in nice and short format, you can write it in expanded form. And if it's written in expanded form, you can write it in short form. Identity law. Which says, well, if I take the union between A and the empty set, it's always equal to A. And also, if I take the intersection between A and the universal set, it gives me A back. Very good. Number 5, complement law. This law states that if you take the union between any set and its complement, it must be equal to the universal set itself. But if you take the intersection between set A and its complement, they are disjoint. They have nothing in common. It's going to be equal to empty set. Recall that we had double negation. Now we have double complement for sets. Double complement, which says, hey, the complement of a set complement is always equal to that set itself. Idempotent law. It says that, well, if you take the union between a set and itself, it's always equal to that set, also for intersection. The intersection with that set and itself is always equal to the original set itself. Universal bond. Well, this guy says, if you take the union of any set with the universal set, it must be equal to the universal set. But if you take the intersection between A and empty set, it's always empty. Our favorite law, De Morgan's law. Well, this guy says, hey, if I take the complement of the union, it's equal to the intersection of the complements. And if I take the complement of the intersection, it's equal to the union of the complements. Our number 10 is the absorption law. Well, this guy says the union between A and the intersection of that set with another set is always equal to set A. Also, the intersection with set A with the intersection with the union of A and B is always equal to A as well. Number 11, the complement of the universal set and the complement of the empty set. So for number 11, we have the following. The complement of the universal set is empty set, and the complement of empty set is equal to the universal set. And the very last law is the connection between the difference between two sets and their intersection. So if you have A minus B, it's equal to A intersection with B complement. So the last law actually connects the set difference with their intersection. Why we're interested in set identities? Because eventually, when we try to prove some statements, we're going to apply these basic rules to help us prove those statements a little bit much easier.